if you look at these pictures right here, it's very easy for humans like you and me to tell what these objects are, right? This is a penguin, this is a tree, and this is a banana. But the very same thing is very hard to achieve by a computer. Like it's very hard for a computer to tell this is a tree. It's very hard for a computer to tell this is a penguin. So how can we let computer do such a simple yet very complicated task? So we can use something called convolutional neural network, right? Or CNN for short. So CNN is a type of neural network that is very powerful when it comes to recognizing spatial patterns within the data. Like it's very commonly used for image-related problems like classifying images, like what this is, what these are. Um, yeah. So um, like I mentioned, it's a type of neural network, right? So what makes it difference from the neural network that we learned in the previous lecture, and um, what's the difference between them, right? So the main difference between CNN and NN is that CNN has a very important layers called convolutional layers. So these convolutional layers essentially just like any other like any other hidden layers in the neural network, it takes input, do something with it, and then output it to the next layer, and then keep repeating that. Okay, but this convolutional layer essentially is this is the whole reason why CNN is able to capture spatial patterns in within the data because of these convolutional layers. We'll talk about it later. Okay, so let's look at the big picture here. Okay, so also this convolutional layers is made out of something called a filter, and this filter is usually a square matrix, right? This filter is usually a square matrix, and this matrix you can have as many as you want, but for this example, we're just going to take one. We're just going to look at one example. So you take these filters, right, and then you the CNN will use these filters to swipe through the image and look for any interesting patterns. I like to think of filter as like the eyes of the model, the eyes of CNN. So it gives CNN a vision. It lets CNN's it gives CNN a vision to look at the images essentially. So if you look at the filters again, we're gonna use a transparent version of the image. So if you look at this image right here, what this filter will tell you is if in the first try you will look at this image, you find something interesting. For example, you find something interesting here, which is the relish and maybe some mustard on the hot dog, right? So we keep doing this, and then you find this important and these interesting patterns. Okay, so this is the main ideas of CNN. So by using these filters, we'll be able to capture, important patterns, important features in the image. So as you go deeper and deeper into the layers, because this convolutional layers thing doesn't just apply once; it's applied multiple times. As you go deeper and deeper into the layers, um, the model will be able to capture more and more complex patterns. Like for example, in this case, maybe in the first try you will only be able to find out the peak of the penguins, maybe the small hands of the penguins, and maybe the top of the banana, right? But in the first try, you will be able to capture something more complicated, like the head of the penguin. Maybe I don't know, like the shape of the banana, and maybe the stem, the root of the tree, things like that. And if you keep doing this for enough for a certain number of time, eventually, almost like magic, you'll be able to classify an image. You'll be able to tell your model will be able to tell this is a penguin, this is a banana, and this is a tree. So this is CNN is almost like magic. Okay, now we are done with the big picture of CNN. Let's get into the nitty gritty and the details about CNN. So here we have the same picture, but I encoded the picture with some values from 0 to 1. So this you can think of this like the pixel values. This is just a simplified representation of the pixel value. In real life, this is probably going to be 0 to 255. But here, this for simplicity, I'll just do 0 to 1. And then here, we have a filter of 3 times 3. I use red color to represent the filter. So what happened is under the hood is you take this filter, right? This filter, by the way, the entries are going to be initialized with some random values, okay? And this random values is a whole another topic. Like not going to get into how to do that. But for now, you're just going to take this filter, and then you literally put it on top of the image, and then you swipe to it, Okay, you keep swiping it just like what I mentioned before. You keep swiping it for every single 3x3 matrix, and for every single swipe, what you do is you do a dot product between the filters and the image, and then with this, for example, if you put the filters on this section, then you will do a dot product between this filter, between filter and this section of the pixels. Okay, the pixel values. So in this case, because this is all zeros, right? And then we have a 0.1 at the bottom right. So the dot product between the filters and this section is going to give you 0.1. And then you keep doing this for every single set, for every single swipe, and then you will also do it for the bottom, and then you keep doing this until the very end, which is the bottom right. And then all the scalar values that you do for every single stripes is gonna combine together into another matrix. In this case, it will be a 62 times 62 matrix. So the size of the output, the size of the matrix of the output, it's going to depend on the size of the filter. So in this case, we have 3 times 3, and because the image is 64 times 64, the output is going to be 62 times 63. And every single entry is the result of the dot product with their respective arrays, basically. And you can think of this, this smaller matrix. It's usually smaller, but it doesn't have to be. For example, if your filter is 1 times 1, then this is probably still going to be 64 times 64. But usually that's not really helpful. I'm just giving you an example. So you can think of this smaller matrix as like a compressed versions of your previous images. This compressed version of your image is going to help the model to tell what this object is by compressing it into something smaller. And then and then after that, you're going to do something called max pooling. This is usually optional, but usually people do it because it actually helps the model a lot. But so basically what it does is it takes the most important features in the previous image again, and then it compresses it into something much smaller, like usually 2 times smaller, but it can also be 3 times smaller, or maybe 4 times smaller. And then you keep repeating this process of filtering and then max pooling, and then filtering, max pooling for a certain number of time. And in the final stage, you would do something called flatten. So you will flatten the what's this called, the image into something 1D. Okay, and from this part on, it's just like a normal neural network. Okay, just like what you had learned before. This is just going to be neural network, and then with a bunch of fully connected layers, and then you would do back prop, forward prop, and then and make a prediction at the end whether this is a hot dog or not. So it can have multiple layers. In this case, we just have 1 layer. 1 layer is totally reasonable, but you can also have 2 or 3. Okay, so this is the general ideas of CNN. And so just to summarize, what you do is first of all you do filtering, you get a smaller matrix, and then you do max pool, and then you repeat this 2 process again and again and again, and then at the end you do a flattening, and then you just from this point it's just like a normal neural network, and then you would do a prediction at the end. Okay, so why do we use neural network? Why do we use CNN again? So people use CNN because research shown that it actually can achieve a very high accuracies on image related problems, like up to 99%. So this is why it's so popular nowadays, because it's so accurate, so powerful. And also, last thing I want to mention, this is just a very simplified versions of the CNN. In later on in the course, you're gonna learn more about it. But yeah, so this is the general idea of CNN, and I hope you enjoy the lecture. Thank you so much for listening.